I'm Rick Hebert with Siemens Government Technologies. Today I want to talk about NX clearance analysis. So the clearance analysis capability is part of the NX assemblies module, and it's not new, it's been around for many years. Today I'm using NX2406. So when I talk to customers about doing clearance analysis, I always talk about three different levels. The first is you should just do a view section. Second is simple interference. And then finally the clearance analysis. So view section will let us see interference in red. Simple interference will check for interference between two bodies. And then finally the clearance analysis tool. All right, so let's take a look at how that would look inside of NX. So let me first double check my load options. Now I'm going to use the minimal load, which is kind of the worst case scenario. I call it the go fast button. Normally you'd want to use fully or partially load, but in this case I'm just going to do it using minimal load. Okay, so let me load this assembly over here, and then I'll do a expand all, and then a pack all. Okay, so a couple things to note. One is I've already hidden the upper skin. We're going to just for clarity, and two is this actuator here is a JT derived, it's a multi-cat actuator with multiple solids in it. Okay, so let's go ahead and do our view clearance first. So the first step would just be to turn on the clip section. And when you're doing this edit section, when you're walking through it, I've got my cap settings set to body color and then show interference with red. So as you're rolling through here, all you have to do is look for red, and you'll notice this actuator has been greatly simplified by the vendor. Since it's vendor supplied, they only give us a simple representation. But you'll notice here there are screws, and these screws are in the same actuator file, but they're showing up as red. So that tells me there's interference there. So by doing this visually, it's an easy way to do it. Now if I look down here between this machined rib and this green clip, I also see some interference. Now this one is easy to miss, so let's pretend like we don't see this. We'll resolve that later. So the first step is just a very simple view section. It's just an easy way to do some clearance analysis. All right, so let me turn that off. So the next way is if I come over here and type in simple interference, run the simple interference command, I can do an interference. Let me go ahead and hide the aft spar. So if I want to do clearance between this and this, and you can either do highlighted phase pairs or interference body. When I say interference body, what it does is it makes an interference body. So if I look at my part navigator, there's an interference body. Now it's a little hard to see, but I've got the see through all. And if you don't have see through all on your ribbon, come over here to the drop down over here. Make sure you have view turned on, utilities turned on. And in the view group, make sure you have see through all turned on. You can also turn on the edit section and clip section. I like to use those a lot. Okay, so here's this body. Okay, so now we know there's interference there. Let me turn that back off, and I'm going to use Control-Shift-K to show the aft spar again. Okay, so let's go talk about clearance analysis. So I'm going to open this in its own window, and then in the assemblies ribbon, we have the clearance group. So in the clearance group, we have the ability to turn this browser on and off, and I've docked this down here. I'll leave that on. So we need to make what's called a clearance set, but if you don't have one, when you do this perform analysis, it will create the clearance set for you. So it's creating that for me. So I'm going to reset this dialog out of the box, and we're going to walk through this a little bit slowly. So I want to do clearance between components. I don't want to do bodies. If I were looking at just that actuator, I could do bodies, but here I want components. So even though the actuator has 6 solid bodies, it's going to treat it as one component. We can either do 1 or 2 collections. In this case, I want to do 1, and I want to do all objects. I'm going to save exceptions for later and clearance zones for later. Here in the settings, I'm going to expand interference and turn on save interference geometry. So it's going to make that interference body for me. And then finally, calculate the penetration depth. Now this always happens with lightweight geometry. But the calculation, I'm going to say exact. Because I've got minimally loaded, I don't want to do lightweight. Lightweight is faster but not as accurate. I'm going to do exact, so this will do exact. So because these are all minimal, it will elevate the load of these and go get the exact bodies for me. That's what this option does here. And then finally perform analysis on OK. So when I say OK, now it's going to go do the analysis. Okay, so we'll let that calculate. All right, so if we look at the results, most of these are touchings. So that's good. So if I click on this right here, I can see those two are highlighted. And if I click this box here, it's going to isolate there for me. Now you notice some red shows up, but if I zoom in, I can't see the red anymore. So what's happening is it's behind the blue solid. So if I turn this see-through all back on, now I can see those red areas and I can see where the rib touches the spar. Okay, so now if I come up here to the hard interference, you can see this one's a hard. So let me turn that one on and turn this one off. And then if I go back to my part navigator, there's a body interference, and this feature was created by the clearance analysis tool. And if we look in there, we can see that it does a calculation and penetration depth. It calculated 11 thousandths. That's about right. Okay, so let's go resolve this now. So when I turn this off, it's going to then show everything. Let me turn this off, and then I'm going to use the control hide tool to let's see, bring back the solid body, and then hide the datums and the assembly constraints. Okay, so let's go resolve this actuator clip. So if I right click and open it in its own window, and then I'll drag this over here to the left. Okay. All right. Actually, here in the assembly, I'm going to hide the outspar again. Okay. So now we can see what's going on here. All right. So we know there's interference here. So if I look, I've got a advanced flange feature. That's the one I want to edit. So if I double click it, I created this to a reference. So in other words, I'm referencing the aft spar face. That's what this represents. But if I look at my bend parameters, these are expressions. So I didn't just type these in, they're pulling it from my sheet metal preferences. So let me go ahead and cancel that. So because it's sheet metal, I'm going to switch to application sheet metal. And then finally I'll go File, Preferences, Sheet Metal. So when I created this part, we were doing our initial sizing, and I just give it a value of 50 thou thick with a bend radius of 3/16. So instead of a value entry, really I need to convert this over. I want to do a material selection. So I'm going to pick from my material tables that my company allows me to use. So I'll just select the material, and what it tells me is there's 14 materials in my sheet metal material table. So I want to pick based on thickness. So when I pick a thickness of 1.6 millimeter or 63 thousandths, it finds that there's two materials in the database that match that. I'll pick this, and then it fills in all the values based on my selection. Okay, so now that I've done that, there's the 63 thousandths thick with a 95 thousandths radius. When I say OK, it's going to recalculate the radius, and now we're good. And we look over here, and we see that the radius no longer interferes. Now this yellow solid is being managed by the clearance analysis, so we'll resolve that in a minute. All right, so this part is now good. So now I'll come back here to my assembly, and my clearance browser now says it's out of date because these two lines are include the clip, so they're out of date. So all I have to do is right click, say perform analysis, and it will clean that up for me. So it gets rid of that clearance body, and now I have a touching interface there, which is as I want. So everything's good. Okay, so now I want to record that I did this. This information is going to be stored in my assembly. So I'll just right click everything and say set to resolved. So now I have resolved that these are touchings and everything's good. Once again, let me do a show hide and bring back that solid body. And okay, all right. Okay, so we're good there. So my clearance information will be saved in this assembly when I eventually save this. So let's go back to my horizontal tail assembly over here. And remember now, the actuator is a multi-solid, multi-CAD part. Okay, so I'll do it again. I'm going to do a perform an analysis. So in this case, I still want to do components. In other words, I don't want to do individual bodies. I just want to do components. So it's going to treat that actuator as a component, not as 6 separate solid bodies. I'm going to leave it as one collection, but instead of all objects, I'm going to say all visible objects. So I've already hidden the upper skin, and I've got 4 screws that hold this actuator in place. I'm going to hide those. So those will not be considered in my my analysis when I run this. Okay, so I could, for exceptions, I do want to exclude pairs within the same subassembly. So because I've already run the clearance analysis for the structural assembly, I don't want to recalculate it here at this level. So I don't have to do that. So we're just going to exclude those pairs. I could come in here and exclude additional pairs if I want, additional geometry, but I'm not. Okay, clearance zones. So I want to do a clearance zone, not between pairs, but around an object. So the object is this actuator. The object is this actuator, and I want a 1/4 inch around that. So I'm going to hit add new clearance zone, and now I get saved down here in my list. So I've got a clearance of a 1/4 inch around that actuator. So save interference geometry, calculate penetration depth, exact, everything's good. Perform analysis on OK. So when I say OK, now it's going to perform the analysis. So we'll let that run. Okay. So now if I click on this, I see I've got touching between the front spar and the skin. I expect that. Touching between the aft spar and the skin. I expect that. And then here I've got a soft interference. It's telling me there's a 20 thousandths distance between the actuator and the lower skin when I had a 1/4 inch clearance. So if I just single click right over here, it's going to isolate that for me. And it's going to show me where it is. There it is. There's that 20 thousandths distance between those two. Well, when the vendor said that we have keep a 1/4 inch clearance around there, they were really referring to the actuator. I don't think they're going to be, that this really isn't a problem. So I'm going to resolve this and set that to resolved. And I'm going to come over here in my text. I'm going to type actuator is clear, and now that will be saved, and then right click and set all these as resolved. Okay, so we've done all our analysis. The last step we're going to do is we're going to go run Checkmate against this. So I'll come over here to my HD3D tools, I'll go to Checkmate, and then I'm going to set up some tests. So in the test section, in the assemblies area, I've got check clearance analysis has been run or not. So if we look at this, it's going to tell us, when it says info, it means the validated part is not an assembly. Passed means that it was run, and failed means that it doesn't have any clearance data set. Okay, so I'll move that down, and then we'll go set parts to all loaded parts, and then I'll execute my tests. So now all of these, it's telling me the part, these are parts, there's no analysis run, that's what that means. I'll hide all my information parts. So my skin assembly, I have not run it on my skin assembly, but on my structural assembly and my horizontal tail assembly, it has been run, that's why we have the green check mark. Okay, so it's all good. All right, let's continue on. Let's go back to PowerPoint. Okay, so let's talk a little bit more about the load options and this calculate using exact if loaded. So in all NX part files that have bodies, we always have an exact body and a lightweight body. When doing clearance analysis, lightweight bodies are faster, but exact bodies give you more precise results. So in your assembly load options, if you're set to minimal, you're gonna get lightweight bodies. If you're using partial load lightweight, you get lightweight. Fully load lightweight display, you'll get an exact calculation. Partial load gives you lightweight, and fully load gives you exact. However, if you toggle this to exact, you will always get the exact, as that's the way I showed it in the demonstration. So here's a case study. Had I done it with lightweight interferences, I would have gotten the lightweight bodies would have told me there was interference. And these are very small. We're off in the 4th decimal place. Here we're only in the 3rd decimal place. So the lightweight gives you false positives. And if you do that, if you just shift click all of these, then right click and say do solid check, it will run it using the exact, and then it'll return you the correct results. And that means one hard touching, as we saw earlier in the demonstration. And this is just a recap of the Checkmate. Okay, so hopefully you found that valuable.